Hello, ladies and gentlemen. This is 6.2. We're looking at antiderivatives and indefinite integral. All right, so before we get into the topics, I just want to talk a little bit about a little more about the relationship between derivatives and antiderivatives. Okay, so let's say we have a function x squared plus 3, right? Now, if we take the derivative of this, we get 2x, right? And earlier we said that if we want to get the to go reverse, then this is the antiderivatives. Right. Now I'm going to introduce another function x squared, and when we take the derivative, we get the same thing, 2x, and then the antiderivative is also this. So one thing you will see is that these two functions, x squared plus 3 and x squared, they both have the same derivative, which is 2x, right? But when you take the antiderivatives of 2x, you actually get two different things, right? X squared and x squared plus 3, where we have this extra constant that we are not seeing in x squared. All right, so the question is, if we integrate 2x, is it x squared or is it x squared plus 3? Right? Or is this something else? Right? And that's something we have to think about. And this is called an indefinite integral. So an indefinite integral is basically an integral with no bounds, right? There's no bounds. No upper bound or lower bound. No bounds. Okay. And this is what we're going to look at in this section. All right. So let's start with something simple again. Let's just focus on x squared. Actually, I'm doing in general x to the nth power. Right. So to take the derivative of x to the nth power, we first have to bring down the power and then decrease the power by 1. All right, so I'm going to write it down. Bring down power, or I should say multiply. I multiply the power and then decrease power by 1. Okay, so the antiderivatives is going to be the opposite of this. All right, this is for derivatives. And for antiderivatives, if we have x to the power of n, to find the antiderivatives, we're going to do the opposite of what we're doing up here, right? So opposite of this thing. So we're going to go in the reverse direction too. So first it says decrease power by 1, right? We're looking at the second step first. So we're going to increase power by 1. And then bring down the power or multiply by the power. We're going to do the opposite, which is divide by the power. All right, so what we have, let's say I want to take the integral of x squared. All right, so increase the power by 1, so I have x cubed, and divide the power, divide the new power, which is 3, so divide by 3. And that is how we get the integral antiderivatives of x squared. And there's one more thing. Whenever we are working with indefinite integral, we have to add some constant c. Okay, now this c is very subtle, right? The idea of this c, you have to think a little about it to understand why is there a c. All right, so let's say I have x cubed over 3 plus 1 and x cubed over 3 plus 2. Now these two functions are very different, right? Right, very different. But when we take the derivative of them, what do we have, right? Bring down the power, decrease the power by 1, we get x squared. And then for the second one, bring down the power, decrease the power by 1, we also get x squared. Now, notice that the +1 and the +2, they are gone, right? Because the derivative of any constant is 0. So this plus c that we have allows us to take into account of different function with different constants, right? Okay. So that plus c is going to affect the constant in the antiderivatives. So we have to include that plus c, right? If we don't have the c, we are assuming that the constant is always 0, which is incorrect, right? Just like what we see in this case. The constant can be +1 or +2 or -5, right? Any constant can work. Also 0 will work, right? But without the constant, you're saying that, okay, there is no constant in the antiderivatives, which is not always the case. So remember to always include the plus c when you are working with indefinite integral. Now, of course, we will see a lot of example today, and let's start with our first integral rules. All right. So the integral of a lowercase f is capital F plus c, right? Where f capital F prime is lowercase f, and c is any constant, right? So this is what we're talking about. We always need to add the plus c, the plus constant, when we are working with an indefinite integral. Okay, now the first rule is what we're talking about, right? To integrate any power function, we add the power by 1 and divide by the power. So exactly opposite of the derivative, right? Derivative, we multiply by the power and decrease the power by 1. The opposite will be increase the power by 1 and divide by the power. Okay, so for antiderivatives, we are going in that direction. Okay. Okay. So let's look at one example together. Let's say I want to integrate. Oh, can't do that one yet. Let's introduce another one. If k is a constant, then the integral of k is kx plus c, where c is a constant, right? And k is also a constant. All right. To give you a quick example, let's say integral of -5 dx will be -5x plus c. All right. Next, we have integral of 1 over x. Right. So remember that the derivative of ln x pushes the x into the denominator. Sorry. So we're doing the opposite. If we have 1 over x with x in the denominator, then the integral of that is just ln of x plus c. Now, notice that we have this absolute value here. Right? It's very important because when we're working with indefinite integral, there is no if there is no condition on the value of x, then we have to include this absolute value around the x, so the function is defined, is well defined. Okay. All right. Now the last one is the integral of e to the kx. Right. So to integrate e to the kx, we just divide k, divide by the constant in the exponent k. Okay. So i.e., let's say I want to integrate e to the 3x dx. Now, if it's taking the derivative, then we would multiply the 3, right? But since we're taking integration, we're taking integrals, we have to do the opposite of multiplying by 3, which is divide by 3. And always don't forget to add a c. Okay. All right, so we have 4 rules, and we're going to focus on these 4 for now. All right, let's look at our first example. We have 8x cubed plus 1 over x, right? So our goal is to integrate this. Dx. Now, just like derivatives, we can integrate them term by term, right? So that means I can integrate ax to the fourth, to the third, dx plus the integration of 1 over x dx. Okay, so the first one, that ax cubed is a power function, right? So what we need to do is we can just add the power by 1 and divide by the new power, okay? And plus c. I'm going to call that C1 because we have two integrals, and each indefinite integral will give us a constant, right? So this is the first constant that we get from the first integral, so I'm going to call that C1. Next, plus the integration of 1 over x, as we know from earlier, is ln of absolute value of x plus c, right? So this is ln of absolute value of x and then plus c. Now, in this case, I'm going to call that C2, right? Because this is the constant that we get from the second indefinite integral. All right, so what we can do now is we can actually combine these two constants together, because keep in mind C1 and C2, they are just numbers, right? So what we can do here is we can combine both of them together, add both of them together, and then rewrite our final answer like this. So a over 4, that's 2. So we have 2x to the fourth plus ln of absolute value of x, and then c1 plus c2. I'm just going to call that overall some constant c. Okay. So each indefinite integral will give you a constant. And at the end, we can actually combine all those constants together and just call it c. We don't have to write out c1 plus c2 plus c3, right? Depending on how many indefinite integrals you have. You can all add everything together and combine it and call it just a plus capital C. Okay. All right, let's do another one. So I have 12 times e to the power of negative times 0.2t. So we're going to integrate this. All right, and dt. Let's go up a little bit and look at the rules we're going to be using, which is this one, right? Let's put it next to what we have here. Okay, so we have the constant 12, which is not going to affect us that much. That's just attached to it. Okay, so just copy down the 12. And integration of e to the kt, we just need to divide k. In this case, our k is the value of 0.2. That's right here. That's k, right? So when we integrate it, we have the same thing, e to the 0.2t, and divide by k. Divide by 0.2 like this. Okay, and as always, don't forget to plus c. All right, and let's simplify this to again. So that's 60 e to the 0.2t plus c. Okay, and yeah, that's it. And this is going to take some time to get used to it, and of course, we will look at a few more examples together in a second. All right, so some of the things that we were using was this, right? In part A and part B. If you're integrating sum or difference of two functions, then you can break it up into two separate integrals, like what we're doing here in part A of the question, right? So integral of f plus g plus minus g dx is equal to integral of f dx plus or minus integral of g dx. Okay, and if you have some constant multiplying the function, then you can bring the constant out and integrate the function. So the constant in front of the function is not going to matter that much. I actually wasn't too clear about this, but let me show you one more example. All right, let's say I have 12 times x to the third power dx. Right. So what part two is saying is that 12 is a coefficient, right? And we can bring that outside and then integrate just x cubed by itself. Okay. And then to do that, we add the power by 1, right? And divide by the new power, right? And then multiply it to the 12 that's in front of it. And the plus c. Don't forget the plus c. Okay. And then we can combine the 12 with the antiderivative. So 12 over 4, that's 3x to the fourth plus c. Now, in order to check if you have the correct antiderivative, you can always take the derivative of your result to check. So take derivative to check answers. Okay, so let's do that. Right? If we take the derivative of 3x to the fourth plus c, right, first bring down the power, so 4 times 3. So 4 times 3x, decrease the power by 1, that's a 3. And the derivative of constant is 0, right? So we don't have to worry about that. That gives us 12x to the third power, which corresponds to our original integrand. And that means we have the correct antiderivatives, right? Now, of course, don't forget the plus c. All right, so here is another example. Go ahead and pause the videos and see if you want to try this one on your own, and we will work on this together just in a second. So if you want to try this one on your own, go ahead and pause the video now. All right, so here we go. First, I'm going to split this integral into two. So first one will be integral of y cubed minus the integral of 6y squared dy. Right? And then I'm going to clear things up a little bit by bringing the 6 to outside of the integral, like that. Okay, so basically we're just integrating y cubed and y squared. So y cubed and y squared, add a power and divide by the new power. Right, so add a power, y to the power of 4, divide by the new power. All right, and I'm not going to worry about the c for now. I'm just going to add that at the end. Okay, and then minus 6y to the plus 1 power, which is 3, and then divide by 3. And now I can add a c, right, to represent the constants from both integrals. Right. So this is a shortcut that you can use instead of doing what we were doing earlier, having a C1 and C2 from both integrals. We can just add a C at the end to represent the constants from both integrals. Okay, so let's simplify it. Y to the fourth over 4 minus 6 over 3, that's a 2. So 2y cubed, and then a plus C. Okay, and then that's it. All right, next we are looking at integrals of sine and cosine. So we know sine and cosine, they are actually integrals and derivatives of each other, except with the sines and stuff. All right, so let's start. Let's say I have a function, right, which is sine x. Now, if you take the derivative, you get cosine x, right? But if you have cosine x, you take the derivative, you get negative sine x. Okay. So if it's sine and cosine like that, if you're taking the derivative of sine or integration of cosine, you don't have to change signs, just like what we have here. Right? They are both positive, but when you're taking the integration of sine, you have to take into account of the negative sign in front of the integral. Right? That's because derivative of cosine is negative sine. Okay. That's where the negative comes from. Now, if you have something multiplied by x, let's say a cosine kx or a sine kx, you have to divide by that k when you integrate, right? Just like when we're taking derivative, we have to multiply by the k from the chain rule, right? So these 1 over k's, right? These are actually from something called the reverse chain rule, right? But for now, we're not going to go too deep about it. Later on, we will see when we look at more general forms, and we will see what a reverse chain rule is. But for now, you can just use these two formulas to help you integrate any examples with sine and cosine. Okay, so let's do one example together. And this example is going to consist of everything that we have up here. All right. Now again, feel free to pause the video if you want to give that a try. All right, so let's do this. First, I'm going to split it up into 2 parts. All right, so we have integral of sine x dx plus, I'm going to bring out the 3 now. So 3 times the integral of cosine 5x dx. All right, so let's look at first integral of sine, which is right here, right? Integral of sine. We're going to use it here, which is negative cosine x plus c, right? Or we'll worry about the plus c later. All right, and then plus 3 integration of cosine 5x. So cosine 5x, we are going to look at this part. It's going to be 1 over k times sine kx. Now in this case, k is 5, right? So we have 1 over 5 times sine of 5x. Okay, and now we can add plus c at the end. Okay, all right, and let's clean this up a little bit. So we have negative cosine x plus 3 times 1/5, that's 3 over 5 sine of 5x plus c. Okay, and that's it. Now let's actually check to see if if this is correct, right? So let's check by taking the derivative of this thing, right? So d dx of this whole thing, negative cosine x plus 3 over 5 sine 5x plus c. All right, so derivative of cosine is negative sine, right? So we have negative sine x plus 3 over 5. Derivative of sine is cosine. And then since we have the 5x here, we have to multiply by an extra 5 at the end. And the derivative of a constant is 0. So I'm just going to put plus 0 here. All right, so negative of negative sine is positive sine. And 3 over 5 times 5 is a 3. And the cosine 5x. Okay, and there you go. We get the same thing. Now check, and that is correct. Okay, so it's always a good habit if you have time on the quiz or exam. Always take a few minutes to check if your integral, if your antiderivative is correct by taking the derivative. So keep in mind that derivatives and integrals, they are opposite operations. Okay, they are opposite operations. All right, and that will be all for 6.2. Now, this is one section where it requires a lot of practice, a lot of problems, and to get used to all these rules and stuff. Now, I know this is a lot of rules I'm throwing at you, but have it next to you at all times, and then after a while, you will get used to these rules without having to look at the notes. All right, thank you guys very much, and I'll see you next time.